Today, I will try to explain a high-level overview of web application ecosystem development using the React.js and the Node.js platform. Before I will start, I will just briefly explain that there are four fundamental goals when defining the architecture for web application development. Start with providing a stable or architecture that allows your application to actually run regardless of the volume of transactions and the number of users, simultaneous users accessing the system. So this involves implementing scalability, load balancing to properly have that kind of stability with almost 0% crash. Most important also is it should be the application architecture should be very fast and responsive, that it allows to provide a very high level user experience that was actually satisfy the customer requirements. Is thirdly, architecture should be future proof, meaning that it should allow integration of future updates and even integration or implementation of new frameworks and libraries. At the same time, the architecture should be flexible enough to be able to handle new requirements and should be extensible enough to integrate new emerging technologies and platforms. So with these four goals in mind, I will go through each of the different technologies that we will be proposing for the implementation of the web application, cloud native web application ecosystem. Now, when developing a web application project, normally it's composed of two different layers. One is the front end, and the other one is the back end. The front end composed of two components, which are the core components and the user interface components. Basically, what the core components does is it's the non-visual side, which involves simple page-specific business logic, like for example, computations and calculations, validations from within the front-end side. This also includes special aspects like state management, internationalization, and all the other non-visual stuff. On the other hand, the user interface is the visual stuff that the user actually can see in the website or in the web page. The third component is the backend, which provides the business logic for your application. So it's basically your API or the backend services. For this presentation, I would like to go through the third component first, and I would like to have a very quick presentation of how this will be implemented accordingly and what are the different technologies that we will be using along the way. Part of the modern web application architecture is to be able to design a scalable and highly available backend services. Backend service basically contains your primary business logic and business workflow. So this is very important to be scalable and highly available as much as possible, regardless of the volume of requests and transactions. So in this case, we will be implementing a progressive microservices using the molecular platform. Molecular platform is one of the more popular and widely used framework for developing microservices in the Node.js platform, not only because it's very, very fast, but also it already have built-in components for implementing fault tolerance. So when we say fault tolerance, that includes load balancing, circuit breaker technology when something goes wrong, something like you have a fallback method to handle unforeseen scenario. We also have retry and timeout mechanism, as well as the bulkhead feature. Bulkhead feature basically is the traffic workflow management already built in the infrastructure. Now, molecular is very, very popular because it already has self-contained features. Like for example, it has the mechanism for metrics tracing. Like if you want to trace which particular microservice is failing, it has also some caching and validating components, discovery and registry, as well as load balancing and other middlewares that you can basically integrate. Now, I would like to quickly demonstrate how this will works together. Basically, if you are developing a microservice applications, the idea is you have a self-contained microservices that serves different functionalities. Now, this different set of services can be distributed in any location, or it can be in different clusters or in a distributed cluster. Now, to be able for each of the microservices to communicate, we have to use a transponder or transporters to be able to have the different components to talk to one another or send events or send messages. And what we will be using is a high performance messaging platform called the NATS. Now, this is basically used for different purposes like IoT, cloud native applications, as well as microservices. This is a very high performance, high throughput platform. In fact, if you look at here, so many companies are already using it, like Sony Ericsson, Siemens, Baidu, VMware, so on and so forth. So this is high performance and can be used in a wide variety of usage. Now, let me quickly demonstrate of how to put things together when developing our microservice architecture. Now, I have here, I have developed a very simple prototype, a microservice prototype. Basically, it has three services. One is the authorization, and we have some example methods also for the core services, as well as the gateway. So in developing a microservice architecture, we have to put into consideration that most of the components are actually deployed could be anywhere in the cluster. Now, to be able to figure out or discover where they are located, we have to communicate to an edge server. The edge server will act as the gateway or the entry point of all the API calls. Now, the edge server or the API gateway will be able to uh, send or redirect your route calls to the appropriate nodes of your services through the NATS servicing mechanism. So let me quickly demonstrate that. So here I have a service API, which I have already developed. Now, just to be able to transparently see how things are going on, I will be running the application in a development mode. Oh, before that, since we will be also demonstrating how the NATS uh, technology or the NATS messaging platform works, we have to run, it's already in a Docker image, so we have to run the NATS server. Okay, so we can verify that. Now I have my NATS server running. Now, next is I have to run the microservices and they should be able to connect to the NATS accordingly. So I'll be running in development mode. Okay. Now, one of the important feature for the molecular microservice platform is it has a console that you can monitor. Now, if you are deploying in the production later on, there are also certain mechanisms that allows you to take control and actually inspect your services from within the dashboard. But that would be in the production side. But for this presentation, I'll be showing you from the console. Now, first thing is we will check what are the different services running right now by sending the command services. So as you can see, I have the out, core, and the gateway. So as I mentioned earlier, gateway is your edge server, which is the entry point for all the API calls. The auth is the authorization server that allows you to validate user access. And for this presentation, I also have the core services just to demonstrate the different methods or actions available. Now, to be able to see what are the different methods or actions I can be called, I can actually type the command actions. Now, I can see here, like for example, the auth service has the authentication, verification of tokens. Core service also has two actions, which is node information and user information. Now, if I want to see also the available nodes, each of the different services can run in one or multiple nodes, or it could be multiple nodes in a distributed cluster. So in this case, since I'm running on my local machine, there is only one node available, and we can verify that and we can see the node ID. So as you can see here, I'm running on my local machine, and this is the IP address. Now, if I'm running in a cluster, I could be seeing multiple IP address here, and I can see that the state is up or online, or it's down or offline, CPU usage, and so on and so forth. So if I extend here, you can see all the information. Now, in this particular node, which is my local machine, I have four services running, which these are the four services which I have mentioned earlier. Now, let's try to call. I have here a simple API call. So first, let's try to authenticate. And one of the important feature of the CLI is it allows you to also monitor all the API calls along the way. So for example, I want to authenticate a user with a username admin, and the password is not for you to know. So if I execute this one, which is a post API call, you can see the you can monitor the API calls from within the console. Now again, as I pointed out, this is development mode, so I can monitor all the activity from within the console. But if I am in production mode, there's a web dashboard that I can do the same thing. I can monitor all the activity. So as you can see here, we have a success response. That's why I get my token. By the way, I just want to emphasize that for this kind of implementation, we are using the JSON Web Token for security purposes. So GWT, all the tokens, all the credentials are signed by PKI or public key infrastructure to make it more secured uh, as a platform for authentication. Okay, so I can monitor here that it's a success call calling to this particular REST endpoint. Now, suppose I want to get, now I have already been authenticated. Now, suppose I want to check if who is the currently logged in user. So I have here a user information page, but first I would like to show if I disable the authorization, but my API, it is mandatory to actually authenticate. If I execute this particular method call, you will see that it will generate a 401 HTTP error, which means unauthorized access. That's why you can also get the response 401, no authorization token involved. Okay, now just for the presentation, I will enable the token, and I injected the token here. This is my token or the GWT token. And if I execute again, now I can see that the current login user is system administrator with an ID admin. And also from the console, you can see that the process is a success. At the same time, I also would like to know, since this is a clustered environment, for example, I want to know which node is actually serving the API request. So I can query the API. If I execute this one, you can see I have a success response, and it's also showing me that this is the node ID 29703. We can verify that by typing the command. This is the node ID as well. Let's see, 2970. Maybe it's a little bit dark because of the font, but this is the node ID corresponding to this one. So if we are in the cluster mode, this could be changing. This could be a different, every time you execute the call, this could be changing node ID because the load balancing feature of molecular. So you can be sent to another node, or it depends on, because the molecular framework has an intelligent load balancing. It has different mechanism. For example, it could be geolocation. So if I am from the, for example, if my request is coming from Japan, I will be forwarded to a Japan node, or it is also be based on latency. So whichever node has the fastest ping time, I will be redirected also to that. So I will show you the molecular framework has different intelligent load balancing mechanism. You can see it from here. So different strategy. We have round robin, which is just a cycle. It could be CPU usage, like if I have multiple nodes and one of the node has already so much CPU usage because of so many requests, then I will be forwarded to the next lowest CPU usage. So intelligent load balancing, and also it has a built-in fault tolerance in case something wrong. So it has circuit breaker, it has the bookkeep feature, it has a retry and timeout functionality. So now, since we will be implementing let me just stop the services first because I want to demonstrate something else. So I will stop the nuts engine. Now, since we will be implementing in a clustered environment, so for example, we will be deploying our microservices in a Kubernetes cluster. So the easiest and the fastest way to actually deploy your microservices is through a container management system like Docker. So Molecular already has the built-in functionality to actually package your application as a Docker image. And we can quickly do that by, like, for example, I will demonstrate. I can run Docker container up, and it will actually build the Docker network for you, and it will actually compile all the application as a Docker image, which basically you can deploy as a standalone Docker application or inside a Kubernetes cluster. Okay, so after compilation, it will actually automatically run the network so that you can access the services, and we can also verify that. You can see I have a Docker container running already, and these are the entry point. These are the ports and everything. So it's very easy for us to actually manage our Docker images accordingly. Now, since we are normally we use the Docker deployment in a production mode. Now, once you are deploying in a Docker container, you also have now access to the different dashboard that Docker have. Like for example, here I can monitor all my traffic from within the dashboard. Remember, as much as possible when you are in production, we try to minimize access to the console. That's why shifting from development mode to production mode, we are now dashboard based. So I can see here that I have services running. I can see also if I have errors or warning, and I can monitor from here. Now, not just traffic. Traffic is just the dashboard for monitoring the traffic flow, but we have several other dashboard available to Molecular. For example, we have uh, Zipkin for monitoring all the API tracing your API. We also have the Grafana for getting the metrics, for example, how many requests per second. All this information you can see from the dashboard and you can monitor from the dashboard. That's why it's very, very powerful feature for developing microservice-based API that allows you to actually deploy load balance in a cluster mode. So this is a very powerful feature. Now, another thing is when you are developing an API is your database access. So, like for example, in our scenario, we might be deploying to a MySQL deployment. So one of the fundamental requirements for us is to have an efficient data access. In a traditional way, normally when you execute a query against the database, first you have to open a connection, authenticate, send a query, get the response, and then close the connection. You have to do this every time you execute a query, and this will actually give you a penalty when it comes to the performance because of the closing opening authentication. That's why one of our requirements and implementation mechanism is to use the connection pool. For example, this one, we have a connection pooling mechanism that allows the connection pool engine to keep the connection pool open so that it can be reused. And you can specify how many connection pool can be opened simultaneously. So this is a very effective to actually improve your connection to the database and to enhance the query speed. Now, we have the connection pool, but remember, our API will be deployed in the cluster. So not only you have to focus on connection pooling, your connection pool manager also need to understand the cluster-based connection pool. That's why in this particular framework that we will be using, we also have cluster pooling. So that means it is cluster aware. It can manage connection pools from within the cluster. And at the same time, to avoid any other performance penalty, all activity notification if there is available connection pool to use or not should be event driven. It should not be synchronous, but rather it should be asynchronous to actually improve the latency and performance. That's why the framework that we should be using for data access must also support the pull events. You get notification in a synchronous mode. So all you have to do is just subscribe and you get notification when automatically initiated by the connection pool manager. So all these pieces together, we will combine data access management, microservice deployment, Dockerized container, cluster mode in Kubernetes, uh, high throughput messaging for our microservices provides a very solid foundation for developing the API. Now let's go to the front end side. The front end side is we will be using the React platform. A good thing is the React development team introduced the new version of React, which is called React 17, just recently released October 2020. Now, why this is very important? Remember when I started the presentation, we want to emphasize that we want to future-proof our architecture. And that is exactly the purpose why they released the React 17 because of the gradual upgrades. So what this means is that later on, as you can see here, let me just try to highlight, when a new version of React, maybe React 18 or 19 or 20, it's much easier to upgrade your application by the mechanism provided by React version 17. So as much as possible, much easier to upgrade. We can avoid any complexities when upgrading to future version of React. That's why we will be implementing this one. Now also, aside from using the latest version of React, we will be, remember in the original slideshow, there are two front-end components. One is the user interface, which is the visual part, and we have the core services. The core services is the internal mechanism of the front end that allows you to implement, like for example, internationalization, image optimization, uh, API routing. This now can be done by a new framework called the Next.js. So this is a very popular framework now. By the way, this is not a competing product of React, but rather it uses the React engine and then create already a framework that already comprised. So like for example, if you are using the raw React implementation, if by default you will be using the JavaScript to actually type in your code. But if you want to switch to the TypeScript, a more powerful TypeScript implementation, you still have to configure the tsconfig. You have to configure the TypeScript dependencies and everything. So many boilerplate that you need to do. But if you use the Next.js platform, everything is already there. In fact, so many companies like Netflix, we have the Ferrari, Starbucks, Uber, Binance. so many major companies are actually using this platform already for developing their website. Even the Docker website is powered by Next.js. Now, again, as I mentioned, it avoids to create manual configuration and boilerplates, and it has already everything that you need to get started, and you don't have to add any more dependency. Like for example, TypeScript support, image optimization, file system routing, code splitting and bundling. Before, you still have to configure your Webpack to package your front end. Now it's everything for you. It's being implemented. Right? So we will use the Next.js, which runs on top of the uh, React platform. Now, I also want to emphasize that there's a new feature introduced by the Facebook development team. If in developing React, one of the key item, especially in the front end, is what we call the application state management. So, like for example, you can use this to store some important information, tokens, application state. The more popular before is we have the Redux, and then it evolves into the MoveX. But I think there are some certain limitation and restrictions. So, like for example, Redux is a little bit complicated for others to use, or maybe once your application state is more complex, it's becoming very slow. That's why the React team developed a new platform called Recoil. So this is again, as I want to emphasize, this is developed by Facebook. Although this is a new item, new technology, or new framework, but a lot of developers are now moving through this because not only it's very lightweight, it's very fast, and it provides new features not available in MoveX and Redux. And considering this is developed by the same team that develops the React core platform, so many users feel confident to actually use the platform. But we will be using this one as well to have our application feature proof and to provide a much better solution for application state management. Now, also, I would like to emphasize that since we will be implementing a business implementation, it's normally required us to choose a reporting tool. Now, what I would probably suggest is we will use the bold reports. One of the reasons why, especially in business application, why this is becoming popular is not only because it's developed by Sync Fusion. Sync Fusion is a widely famous component development company. And in fact, if you can see here, the bold report is used by more than 260 Fortune 500 companies, and they have been in the business for more than 18 years. They're basically developing a lot of components for web developers, designed by developers for the web developers. And Syncfusion is very famous, and in fact, you can see here some of those companies that are using their products are like companies like IBM, Intel, Visa, and and so on and so forth. That means there's a high degree of reputation this company provides. So, so this is a very good addition to the architecture that we will be developing. So now we have the UI side. We also have the API side. We have the microservices. We have the data access efficient. We have the messaging architecture. We have the front end. We have the latest version of React. We have the Next.js for our core services. We have Recoil for upstate management. We combine them together and propose to actually propose a very solid web application ecosystem. Uh, at the moment, this is a very high level introduction, but in the next few weeks or days, we will now combine them to create a prototype that actually integrates all the different components from the UI, core services, core API, core layers, as well as the API. And then I will demonstrate how the ecosystem works, how they are interconnected, how is the access, how they respond, so something like that. So In the next presentation soon, I will demonstrate that to you. At the moment, this is just a high-level overview, but just to give you an idea of a very good foundation for developing a web application ecosystem using the modern approach. Thank you very much.